this is Udit. Hey guys, this is Udit, and today we'll be learning basic maths for algorithm. So why we want to learn maths? Because it tells us how our algorithm grow and how our efficient, how much our solution is efficient. How can I reduce a big problem into smaller ones? And other things like recursion and other things, logarithm. So let's move into what is logarithm. So logarithm is basically it is to find out like how much power it has, like power of 2. So log 2, I mean log anything, but in computer science we do log power 2 because we divide everything basically starting into 2. So log 2 for 8, so 8 will be like 2 power 2 for power 3, it will be 8. So the answer will be 3 because 3 will go into its, it will multiply log 2 for 2 with 3 and the value will be 3. So it will be like this. So 3 into 1 will be 3. So this is how it is. So because computer divide 2 is like I told. So why we learn this log 2, and why we learn log and why we specifically learn 2, because it basically divides into two different paths to. So binary search is there, height of binary tree is there, because initially it was based on that only. Heap height is there, and if you divide by 3 only, it won't give a considerable increase in this thing, because if you divide by 2, then parallelly it will divide by 2, it will divide by 2. So it is like that only. So it will grow in that manner only. So it is like rather than following one path, you are just allowing to follow just one more path. So it's like that. So logs in real life, so if we split the work, then it is log actually. So it's like that. And this is the important log formula. If log a into a is then log a plus b, log a minus b, and this thing, it's like that. B is like log b minus log a, and we can give any base log also for that. So BIGO is that BIGO is BIGO is basically the maximum amount of time, which is it tells BIGO, and everything tells the growth rate of our algorithm. So BIGO is the maximum amount of time a basic thing will take. I mean, basic our algorithm will take the maximum amount of time to run a particular task. So O1 is constant, O log n is logarithmic, O n is linear. So constant means that it will take so constant means it will take 1 second of time or 1 unit of time. So example is hash lookup. So hash lookup means that suppose in a hash map is like a key value pair. You go for a key, you will get a value. So it will take a constant time. So it's like that. Log n means binary search, means you divide something into 2 and then again you divide into 2. So suppose there is an array of 10, you divide into 5, then again you divide into 2 other half of 2, and then started searching into it. So what you found that the size of the whole data structure got divided or got consistently subtracted or reduced into halves. So it is log n. And there is linear like on. Log linear is like n log n, and then quadratic is n square 2n, this thing. And then log n is dividing work into half repeatedly. Log n is also similar to that, and n log n is also similar to that. So it's like that. So it's like that, guys, only. So guys, this is binary search, which is tn, which is like dividing the whole into 2, set into 2, and then plus 1. So it's take log 1 time. Recurrence basics. A recurrence is like a formula that describes how big a problem is broken into sub problems. So this basically tells if there is size of n, then n is 1000, then log n will be 10. If it is n, then it is 1000, then n log n, then it will take 10,000 times. So it takes how much, how fast it growth. The growth is n square, means if you are writing a loop, then it will take this much time. So n square means writing a nested loop, so that much time it will take for processing. So this is a recurrence relation. Recurrence is like a formula that describes how big a problem and breaking into sub problems. So suppose n is the size of this thing, so t n by 2 is means dividing into 2 plus 1 log n. So this is for binary search. Reason each step divides the array into half. So that's why they are using this particular formula. Similarly for DFS, so once we start tree traversal, which is also n by 2 only, we'll be able to understand it in a better way. Merge sort also is like that. It's n log n. It is on because it is tree traversal, so it will, it will go to all the nodes, so it will be on. But I mean, in detail, we will understand the recurrence formula once we will do it. For now, it is like a formula that describes how a problem is broken into sub problems. And this is for a simple recursion tn minus 1 because it is called for a small unit of subset of this thing. Tn n minus 2, and this is for Fibonacci series. And so this is master theorem. You actually need just this. If you split into two sub problems and outside work, so master problem is basically finding the time complexity and this thing for this particular. So you actually need just this. If work splits into a sub problem of size n divided by b, the outside work is o n power n to the power d. So it's like that. So modular arithmetic, this is basic how so 15 into 5 into 3 is equal to 15, so divided by 3 it will give 2, so 2 is the remainder, so it gives the remainder. Prevent integer overflow, hash table, rolling cache, circular behavior like rotating array index. So these basically are just things which we'll get into once we will solve the problems for this particular chapter, and that's how it is. So guys, I hope you would like this video. Please stay connected for when we will solve question for this particular lesson. Thanks.